This video explains the different phases of bacterial growth and inactivation. In cases of bacterial growth, we typically see three phases: the lag phase, the growth phase, and the stationary phase, which is sometimes referred to as the maximum population density, or MPD. However, the bacterial growth phases are not simply linear lines with sharp intersections. In fact, the intersections of these phases show smooth curves as we go from lag to the growth phase into maximum population density. We call the transition from the lag phase to the growth phase the N curve. This curve represents the distribution of growth rates as bacteria leave the lag phase and then begin replicating at similar rates and enter the growth phase. You may be familiar with the term N curve if you use the DM Fit for Excel that is available on the ComBase website. The transition from the growth phase to the maximum population density phase is referred to as the M curve. And again, it's a distribution of bacterial growth rates as they leave the growth phase and then transition into the stationary phase where replication ceases. Again, if you use the DM Fit for Excel, you've seen the M curve function. The factors that influence the lag phase include the physiological state of bacteria. For example, the previous environment may have had a lower water activity before the cells entered a new environment that has a higher water activity. The time that is required for the cells to begin replicating is a reflection of the work to be done. And by this we mean this is the work that must go on inside of the cells, such as metabolic changes and genetic expressions, when they move from one environment to the other. The environment also has a very strong effect on the growth phase, or the growth rates. Factors that influence it include temperature, pH, water activity, and nutrient levels. The stationary phase is affected by limiting substrates, microbial competition, the production of toxic metabolites, as well as quorum-sensing compounds. In the case of bacterial inactivation, we can see different types of curves, which are the result of thermal and non-thermal forms of stress. A common profile of thermal stress is linear inactivation. In this instance, individual cells in the population die at a similar rate. However, populations of bacteria can show two different phases of inactivation. This may include a shoulder, where the bacteria displays slower inactivation, followed by linear inactivation. Another inactivation profile may occur where bacteria die in a linear manner, as we saw earlier, followed by a tail of resistant cells. Finally, a three-phase inactivation profile may be seen, such as that with non-thermal stress, where we see a shoulder, linear inactivation, and a tail. For more information, please visit the help sections in ComBase. If you require further assistance, send an email to contact@combase.cc.